Hello, my name is Gulshan, working as an assistant professor, AI and DS department, SNS College of Engineering. So today I am here with the next topic called Naïve Bayes model and the Wampus world revisited. So these two topics is one of the important topic that is dealt with this probabilistic reasoning unit. Okay, now we will see what is this Naïve based analysis. So the Naïve based technique is something which comes under the supervised learning technique that uses the probability theory based analysis. So it is a machine learning technique that computes the probabilities of an instance belonging to each one of many target classes given the prior probabilities of calculations using individual factors. Okay. Now this Naïve based technique is used often in classifying text documents into one or of multiple predefined categories. Naïve based algorithm is easy to understand and it works fast. Now it also performs well in multi-class predictions such as when the target class has multiple opinions beyond binary yes or no clarifications. Okay. Now this Naïve Bayes can perform well even in class of categorical input variables compared to numerical variables. Okay. Now this Naïve Bayes model in this abstract Naïve Bayes is a conditional probability model for classification purpose. Okay, the goal is to find a way to predict the class using a vector of independent variables. That is, finding from x, which implies y. In probability terms, the goal is to find p of y slash x. That is probability of y belonging to a certain class of x. Y is generally assumed to be a categorical variable with two or more discrete values, that is different values. Okay, now in this we have given an instant to be classified represented by a vector x is equals to x1 to xm and features independent variables. The Naïve Bayes model assigns to an instance probabilities of belongings to any of the key class. The class K with the highest posterior probability is the label assigned to the instance now. Now, when we see the Naïve Bayes model, the posterior probability of it is calculated by the function of a prior probability and current likelihood values as shown in the equation. We saw these equations which is related to the Bayes normal Bayes rule, right? So that is something which is related to it. So P of Ck slash x is equals to P of Ck into P of x slash Ck divided by P of x. Now what is this posterior prior probabilities and current likelihood? Posterior probability is the probability that you will be determining or defining the values in the previous process or the process which is going. That is after, the process which will be doing it in the after part. Prior is something which is given already, so that you can take those values and find the values of P of Ck slash x. Now what is this current likelihood? Current likelihood is the values which you actually have in the hand and you can do the values and you can do the process based on it. Okay, now this Naïve Bayes model, you have a simple classification example. Suppose a XYZ company needs to predict the service, okay, of how the process is being executed and all. Now we have two companies of R and M and they have been given the values of K also. The value of K is 2. Now in this first step is to compute the prior probabilities. Prior probabilities is, say for example, they have gathered some information out of the data where 2500 customers they go for opting for R and 1500 customers they go for opting for M. Now what is the probability ratio? It will be around R will be 5 slash H, that is nothing but 2500 divided by 4000 gives rise to 5 divided by 8 and M will be 3 by 8. Now who is having the greater value? It is nothing but R. Now when you come to the other turn, so the next clock begins. Okay, now in this position M gets the higher probability. Now M will be taken into account. The same way in the next possibilities, whenever you are calculating, you will be taking two values as 5 by 8 into 2 by 5, that is 10 by 40, and the next thing will be 3 divided by 8 and 5 divided by 3 divided by 5, that is nothing but 9 by 40. When you see these expressions, who is getting the greater value? It could be R or M. Who is getting the greater value? It is nothing but R. So when you take the next cycle of values, you will be getting some other ratio, and now the probability of R is 1 divided by 5 and M is 4 divided by 5, which is nothing but the customers which come for M is being now a greater value. Now when you calculate, you are having the value as M as the highest value. So the thing which we are actually seeing is, in naive Bayes model you will be having different values, and it will be always be changing based upon the values which you are actually giving. So it depends based on the current value which you are actually giving. So now what is these advantages and disadvantages of this naive Bayes model is, it is simple, and you will be using the conditional probabilities can be computed for discrete data and for probabilistic distributions also, and it assumes that all features are independent. Okay. Limitations for NB is that the posterior probability computations are good for comparison and classifications of the instance. So these are the basic values of how the naive Bayes model is actually being implemented. The next video we will see like how the Wumpus world is actually being implemented and the process which is being done in the Wumpus world. As of now, thank you.